Okay, welcome back to trigonometry. As you remember, the t-shirt of disgust was getting really too disgusting, and I meant to take it home over the weekend and wash it, but I didn't because I'm lazy. Today, we're going to be continuing our discussion about the law of cosines. And it's a really remarkable understanding, and it does a lot of stuff, which is the important part of it. And I'm going to remind you what it is, and we're going to do some more stuff with it. But I also want to show you that it has some shortcomings, just depending on what your information is. And we'll see this in a moment here. Okay, t-shirt of disgust, thank you. Remember the law of cosines. That one's no good. For this generic kind of picture, the capitals represent the angles in the corners, and the little letters represents the lengths of the sides. And this is always the picture that you need. As I said, when you're talking about this in class, it's really hard saying, I suppose, angle C and side C. Usually I end up saying C, and nobody knows what I'm talking about. So remember, these are these angles here, and here. And what does the law of cosine says? Well, it says that little a squared is equal to little b squared plus little c squared minus 2bc cosine A, or little b squared is equal to a squared plus c squared. The one over here, this one is missing from this side. That's how you remember. So b is over here, no b is over here. Minus 2ac cosine, except for the angle b. Side A, angle A, side B, angle B, and once again side C, c squared equals a squared plus b squared minus 2ab cosine C, angle C, side C. This is the law of cosines as we've written it, and we proved it a couple lectures ago. It would be great if you could prove this. If you're not a mathematician or a physicist, you're probably not going to spend a lot of time proving things. Okay, so does it have any shortcomings? Well, what about, suppose that we know, suppose we have 40 degrees, b equals 10, and c equals 12, and I just made these numbers up. This is a perfect situation here to solve for A, because look what we got. We're looking for this. We have B, C, and cosine of A. That's fine. So that's great. Suppose we don't have this. Suppose we have A. We'll let this equal 12 now. What if I have this? I have we have the angle. We have the side A. We have the side B. Can we actually figure out, suppose we want to figure out the rest of the stuff, or specifically, I want to figure out what little c is. Well, let's see. Little c is going to be a squared, which in this case will be 12 squared, plus b squared, which is 10 squared, minus 2 ab, 2 times a, which is what, 12, and b, which is 10, times cosine of c. Uh-oh. Got a problem there. Now, because I'm missing 2 of these angles, if I had one more angle here, I might be okay, right? If I knew that this was, I don't know, 30 degrees, then these two would be 70, and this angle C would have to be 180 minus 70, and that would be 110 degrees. However, if I'm missing this, can I solve this problem easily right here? And no, not easily. Can I solve it at all? Well, it's possible that we can use some of the other facts that we have. We know that so we know that a squared, and I guess I'll bring this over here. So we know that 12 squared is equal to b squared, which is 10 squared, plus c squared minus 2 times 10 times c times cosine A, right? This formula here is A squared is equal to B squared plus C squared minus 2AB cosine A. I have everything here but C. So maybe what I can do is solve for C using this formula. So we didn't run out of luck here. However, this is what we're going to end up here, is we're going to have a quadratic. And I guess I don't really want to go through it. What I wanted to do was to show you that the law of cosines, which is incredibly practical and a great, great boon to anybody doing trigonometry for any practical purposes. But the law of cosines also, like anything, it works depending on how much information that you have and what specific information. During the course of this week, we're going to be talking about the law of sines, and the law of sines together with the law of cosines are very, very practical. And they can solve most problems that give you any information at all worth having. Once again, the t-shirt I've discussed. And now I'm just going to work some more of these problems so you can see how this is done. You might have noticed there was a little edit there. Had a little slight glitch in our reality stream. Okay. These are homework problems that you get to do. Oh, let's see. Oops, well, this isn't the right section. I didn't think we had done that yet. Okay. Picture 29. A weight is hung by two cables from a beam. What angles do the cables make with the beam? As you can see, this is a great problem. If anybody doing construction is going to love this problem. So here's the beam. We have cable tied up here. It's hanging. And here it's tied up. There is a weight. It looks like this. Okay, and the information we're given is this is 50 feet, and this is 65 feet, and this is 100 feet. We are supposed to figure out what these angles are. Okay, so now we have a new picture, and this is what I said before. So right now, all we have is the length of these sides. We don't have any angles whatsoever. And let me look at the picture. I don't believe, no, there's no right angle anywhere in here. So this is great. Let me take the picture out of the frame here just so we can kind of draw something over here. Okay, this is a little too perfect looking. It's important when you draw your triangles to make them not look too symmetric like I keep doing by accident. Okay, so this looks something like it. So here's 50, this is 65, and this is 100 feet, and we're looking for this angle, and this angle, we'll call this A, so this is little a, this is B, so this is little b, and this is C, so this is little c, and I need these to make my formula come out okay. Okay, so I'm looking for, in this picture, angle B, which I wrote angle A, and angle C, and we'll be right back.